Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many ways can 6 identical hardbound books, 3 identical paperback books, and 3 identical boxed books be arranged on a shelf of a bookstore? We are going to assume here that all these 12, that's 6 plus 3 plus 3 books, can be placed on one shelf. We are going to look at the use of permutation in solving for the number of ways where all of these books can be arranged on a shelf. However, there's one concern. We all know that before we could use permutation, that there should be no repetition, and that's already checked here because once you place a book on a certain placement, you can no longer place it on another. The thing there is, the second concern is for it to be called permutation, whenever you rearrange a certain placement, say for example placement 1 and placement number 2, or book number 1 and book number 2, if you just simply rearrange them, that is automatically another arrangement and counted differently. That's another permutation. However, take note that our books here, specifically for hardbound books, there are 6 identical books, meaning these books cannot be distinguishable. If you're going to interchange one hardbound book to its another identical hardbound book, how would you know that that's a different permutation? Supposedly, it should be counted differently. This is why we have another formula for permutation of n distinct objects. So we have this formula here, P, which is indicated by this formula. We have n factorial for our numerator, and this will be to be divided by the number of distributions for each of the n, because we all know that n here is 6 plus 3 plus 3. We have 12 books, and we are assuming that all of these 12 can be placed on one shelf of the said bookstore. Our denominator here will talk about the number of permutations for each kind of identical objects. We have 6 hardbound books, so we're going to have H for hardbound. We will have it as H factorial. For our paperback books, let's just use P for us to be able to identify the correct number. Then we have here the boxed books. We also have that. So this is the formula for the permutations of n distinct objects. Take note that our H hardbound books, we have 6 of them. We have 3 paperback books, okay, 3, and we also have 3 boxed books. Take note that the sum of these 3 must be equal to the total number, which is 12. In short, we have here 12 factorial for our numerator, to be divided by 6 factorial times 3 factorial times another 3 factorial here. Take note that the factorial notation can be expressed in this manner. Let me use some spaces here. N factorial stands for the product of 1 to n integers. Okay? Or we could do it in the reverse order. N times n minus 1 times n minus 2 until we reach 1. In short, our 12 factorial can be placed like this. 12 times 11 times 10 times 9. Okay, I don't have much space, so let me do it again. Let me place that here. Okay, so you have here 12 factorial is 12 times 11 times 10 times 9 times 8 until 1, right? Times 7. But let me stop at 6 factorial. Even if I could automatically continue that further, let me just stop there. Because once I will have that, my denominator already contains 6 factorial here. And it will be easier for me to cancel that because both of them can still be expressed as 6 times 5 times 4 times 3 times 2 times 1, right? But it will be easier for me to compute this by canceling items which are possible to do so. Okay? Of course, I have calculators. I could try using the calculator, but for a longer process, I'm going to present this for you to be guided as well. Now, how about the 3 factorial? 3 factorial is actually 3 times 2 times 1, which is equal to 6. 12 here is actually 6 times 2. So once I'm gonna divide 12 by 6 here, I still have 2 at this point here. Okay? Now we still have another 3 factorial here, which is again equal to 6. But I don't have 6 here, so I cannot cancel 6 anymore. However, take note that 9 is actually 3 times 2, right? 3 times 2, that's, 3 times, my bad, 3 times 3, that's our 9. And together with this 2 here, hopefully you are following that this was 2 earlier because 12 divided by 6 is 2, but this 2 can further be cancelled with this 3 here because 3 times 2 is 6. What remains on my numerator would be the integers 11, 10, 3, 8, and 7. I'm doing that such that my denominator will now equal to 1 itself. Once I cancel all of this, I remove 6 factorial earlier with this, the 3 factorial which is 6, I remove that with 12 which is 6 times 2. The 2 here is paired to 3 for 3 times 3 which is 9, which is also cancelled together with another 3 factorial which is 6 here. So with that, I'm just going to multiply the remaining numbers. That's 11 times 10 times 3. Take note, I don't have 9, I have only 3 here, times 8 and times 7. Again, I have here 11 times 10 times 3 times 8 times 7. The result of that would be the total number of arrangements or ways for us to arrange these books on a shelf on a bookstore. That's 18,480 ways. This is what happens because we have here identical objects, and we do that using this formula for permutations of n distinct objects. This is the answer for this item, and that's count it in. Talking about getting the luck of the draw. For all in, subscribe now.